Just really had a good time at this conference, and I appreciate the spirit in which ideas have been shared. Just some observations I thought it would be appropriate to start with that I've gleaned from things I've seen this weekend. And this may be fairly obvious. IBL works by establishing practices. And by practices, I mean routines, habits, and maybe you might even call them rituals in our classrooms that promote student inquiry. And I guess a corollary of that is that student buy-in, this is a coveted thing, something we talk about, where we're always shooting for student buy-in, happens in part as students become accustomed to these practices and begin to regard them as natural. So, like I said, this may be an obvious observation, but I think it's a good way of framing what I want to talk about today. And you may be familiar with this template of how to set up a gentle IBL classroom, but my motivating example is drawn from this article, Gentle Discovery Method by Ted Mahavier. And what I'm going to try to do is apply that to introductory statistics without completely butchering it. So Ted's not here, so I'm good. I came to teach Math 5, we call it, introductory statistics, this semester, facing certain challenges, I would say. And among those, this is an introductory course with no prerequisites that's taken by non-math majors that are fairly unmotivated, math-phobic, this is a course that's not widely coveted. And I'll confess that the professor of this course was also not terribly motivated. I think I had passively avoided teaching this course for several years. And this is my first time teaching this in a long time. So not really my favorite course to teach. I just kind of got roped into it, and so started with a bad attitude on my part. You're facing a wide variance in quantitative skills. There's some pre-med majors in there, biology majors. Then there's some majors in the humanities who have barely passed the entrance requirements and have very little algebra skills at all. And many students avoid this, even though it's required for certain majors, kinesiology, political science, sociology. They avoid it till their senior year because they're not keen to study mathematics. And there's also a technology component, which I think is challenging because one wonders what sort of balance you want to strike in teaching them how to use certain tools, which tools to use. Everybody has a different platform, different ways of doing things. So I saw these as maybe 4 challenges, which I hope would be addressed by this gentle IBL modified Moore method course structure. So the focus of the course was on a problem sequence. And one of the things in Ted's paper that I referenced earlier that he says, and he was maybe giving an example of a pre-calculus course or something on that level, was that he takes the students through a problem sequence and writes the problems on the board. And he made a point of saying, I don't actually give out a sheet with the problems on it, but the problems go up on the board. This forces students to take notes. And I don't know if this is necessarily important. In my full IBL classes, I give them the notes a bit at a time, and they have the sheet and they can work forward. I think, and again, this gets back to the idea of practices or rituals. I think the ritual or practice of them expecting, in this gentle IBL fashion, me to write problems on the board, which I annotated with a P. So P1, P2, and we got up to, I don't know, P88 by the end of the semester. That became a practice or a habit or a ritual that I think the students bought into. As they were taking notes, you can see when I started a heading, P43, people would perk up and they'd say, okay, this is important. It's a way of emphasizing that the problem sequence is what the course is about. Another ritual we established was Friday is presentation day, and I think this was very pleasant for a lot of them. just knowing there's going to be a rhythm to the week. And Friday, Dr. Hunter will not be up at the front of the class at all. That they were expected to come prepared to present any of the problems that were due that day, and I would choose randomly. This was a class of about 32 students, so I couldn't have everybody present every Friday, but they knew that they had a non-zero probability of being chosen every Friday, so they had to come at least prepared to present every problem. I gave them a couple deferrals, so if they got chosen, they had a couple passes they could use, and that system worked out pretty well, except for the people who hoarded their passes till the end of the semester. We almost looped the whole class. But Friday being presentation day, I think turned into very fruitful discussions and a very good way of framing the work that we're doing as collaborative. And an important component of Friday being presentation day is that all the presented problems go into a portfolio. And these students, though they may not have very good math skills, they do have good writing skills in general. And they did buy in to my repeated instructions that the portfolio is important. The portfolio is really your textbook for this course. And I was just so impressed with the work they did in their portfolio. I'll show you a few snippets of student work in a minute. But I think for the most part, especially the better students, ended up with a 3-ring binder with all the problems and all their own explanations written out and my comments put in there, interleaved in my feedback sheets. I think it was something that they could be very proud of and would actually use as a reference in the future when they had to use statistics for those kinesiology or sociology classes. Another component was web work. The ritual of web work was that it was due at 2 a.m. on Tuesday. So they never had to worry if there was a web work assignment. It was always 2 a.m. on Tuesday, with the idea that after presentation Friday, Monday would be spent answering questions, generally because they're writing up their portfolios from the presentations. They're working on the web work that's due that evening. So I think this developed a nice rhythm to the class. I did have a couple online texts, but I wouldn't say that I used them extensively. I kept my own course outline based on my own problem sequence and the topics I wanted to cover. I'll give you URLs for those. One of them is called Online Statistics Education. This is out of Rice University, and another one is called Collaborative Statistics. It was nice just to have 2 references there so they knew, okay, I don't have to buy a textbook for this class. There is a textbook for this class. So there are some formula sheets in there that might be valuable to have written down somewhere. But those, by and large, weren't drawn upon too heavily, except for the case studies in online statistics education, which I thought were the best part of the book. And I had several case studies using real data that were explained how the data was collected. And we referred to these throughout the course. So early in the course, you're taking averages and medians and drawing box plots and funny things like that. And so we use the case studies. We use a case study on drugs for attention deficit disorder, a case study on anger in athletes. There was a case study on flatulence. There are just a wide range of case studies, and then we'd use these throughout the course, so we'd keep coming back to them, so they'd know, okay, we're talking about the ADHD case study. And you could see throughout the case studies, you could apply different statistical techniques to the data as you went through. And that provided a common thread, and something I think they were comfortable with. So just let me throw up some student work up there. So these are just scans of different students' portfolios and examples of the types of questions I asked in the problem sequence. So there was a talk earlier that referenced given example type problems, and I think in statistics these are very easy and valuable problems to come up with. So just early in the course, and maybe in the first assignment, create a data set. And you can see the students have transcribed what I've written on the board, so they transcribe what I write differently. And sometimes it's interesting to see how they transcribe it. I found it very interesting reading these portfolios. So give a data set, 2 data sets with 4 numbers each, so the median is the same, but the means are different. And I don't know how deep this is, but you can see that student 1 thought that for the 2 data sets to be different, all the numbers had to be different. And she got it to work. Student 2 repeated some of the numbers, but not all of them. And I thought, well, the way I would approach this problem is just pick a data set, and then I would just change maybe one of the numbers on the end of the data set. That's sort of my gut instinct as to how this would work. And getting at outliers, how median doesn't capture outliers, but mean does. So you can get these portfolios back, and this is the wonderful thing about IBL, is you really can regularly see in presentations and in portfolios student thinking. And you can see what they're missing, and you can infer what they're thinking. So it's a richer experience. It's a simple problem, but still, I think even in the simple problems, there are rich things that you can learn. Another example of a given example problem, lurking variables is a concept students struggle with, getting the idea of a variable that's possibly a third cause for 2 correlated variables. So instead of what you see in most statistics texts, scenarios identify the lurking variable, the obvious given example problem is give an example of your own lurking variable. And then I threw in the wrinkle that the correlation you're looking at has to be a negative correlation, and that the third variable is a third cause variable. So this was a problem they didn't really all do correctly, but it's a problem that does get discussion going, especially when a wrong answer goes up on the board on Friday. And again, you invite the students to, you grade very generously these presentations. You invite them to fail, to correct each other's work. The presentation grades were almost all A's. So the grading there functioned mostly as incentive. This is you obviously can't read all this, but another given example problem. Just make up your own between subject scenario, between subject experiment, and within subject experiment. And again, I was just so impressed where some students really took ownership of problems like this, brought it to something that they cared about. This would be a kinesiology major. And just very detailed description of the experiment he'd go through, but it does get him to process the idea, the difference between a between subject and within subject experiment. Another type of problem you encounter, so there might be more rote calculations, where you ask the students to explain their reasoning. And they come to class, or they see that we're explaining our reasoning to each other on those Fridays. So in their portfolios, I stress that they have to explain their reasoning, and they do it. And I was just very pleased. So you can see I mostly require them to type their portfolios unless there's a lot of symbols and they can write neatly. They're allowed to write, but anything that's prose is supposed to be typed. So this student is maybe bending the rules a little bit, but you can see at the bottom she's very clearly expressing and explaining to someone how she's computing the mean just from a frequency distribution. So I counted that as a victory. So just really briefly, I have about a minute. My take on technology was to give them several options and not tell them how to use any of it. And I thought this might be a disaster, but it actually worked fairly well. And I motivate it by saying, well, when you use statistics, you are probably going to be given some statistical package that you need to figure out and learn, and they're all pretty much the same. Here are some free options. PSPP is one, which is like a clone of SPSS, but it's free. You'll get a lot of information. You have to figure out how to interpret it. So the sort of portfolio problems were vague, didn't actually tell you what test to do, but ask you what question you were supposed to answer. And this worked pretty well. I didn't get a lot of whining and complaining in office hours. And just really quickly, I think one thing that made the feedback sheets work, or the portfolios work, was I gave very detailed feedback. So I spent a long time grading the portfolios, which I collected every couple weeks. maybe 5 times during the semester, I'd have to devote the better part of a day to grading a class of 32 portfolios. And I think when they realized I'm giving them detailed feedback, they put more effort into it. So that's a feedback sheet for a very good student with really nothing wrong with the portfolio, but still I managed to come up with a lot of things to say. So anyway, I hope that's a template that's helpful to you. It sure made teaching statistics a lot of fun for me, and I actually wouldn't mind teaching this course again, which is more than I expected at the beginning of the semester. So thanks for your attention.
Thank you.
I'm teaching this in the fall, and I was wondering if you'd be willing to share the data set or your problem sets that you have.
Sure. If you'd leave me your email, I can email that to you. I've got some links here to places I got data. So I've got printouts of those links down here too if you're interested. But yeah, if you just give me your email, I can check it off on my thing. I can email you. Like I said, I wrote them on the board, so they were somewhat improvised in class, and the things I have written out are not for public consumption. And if students never asked me if they were absent, they never asked me to email me the problems. And if they had, I would have said, well, you can just get those from a student. But I think I set those ground rules up early that you're going to have to pay attention when I give you the problems. So yeah, Mondays and Wednesdays, I guess they were mostly lecture, but I did develop a ritual of starting with some sort of collaborative activity every Monday and Wednesday. And really, there were always questions. And just the process of getting the problem sequence on the board developed, I think, a healthy brand of interaction. So it wasn't a one-way lecture most of the time on those Mondays and Wednesdays. But it was a very relaxed ritual I think we got into.
This idea of ritual reminds me last year of something Dylan Retzik said at the prep workshop. The mantra was chop wood, carry water, use definitions, and yeah.
Can you give just some ideas of how you went through and decided how you came up with the problems? I mean, I know assuming not just pulled them out of thin air, but like what the process was to come up with the list of problems, maybe.
Well, I think about Sally's sociologist and what I want Sally to be able to do in a year or two from now. And I don't know. Like I said, the given example is a good starter. Giving them data to analyze and a question about the data, but not telling them which tests to use is I think, a good go-to. That book, onlinestatsbook.com, in the case study sections, after each case study is a list of questions, and some of them are just excellent. And so I kind of modified a lot from there, too.